So let's consider this question, alright. Add two numbers without using the plus operator. Oh my god, how do I add them? We have studied from elementary that add is nothing but using plus operator, alright. So how do I add two numbers without using a plus operator? Well, right, it's quite interesting, right? So let's look at it, alright. We have to find the plus operator's synonym. That is exactly the point of this question. Alright, suppose let us be two numbers, okay, 10 and 8. How do I add it? 8, 4, 2, 1. So 8, 9, 10, 0, 0 and 8, 9. So when I add it, what is going to happen? 0 plus 1, 1. 1 plus 0, 1. 0 plus 0, 0. 1 plus 1 is going to be 0, 1 carry over 1. Right? Makes sense? So this is going to be what? This will be 16 right here. So 16, 8, 4, 2, 1, which is typically what? 16 plus 2 plus 1, which is 19. 10 plus 9, 19. Okay? Getting it? So this is what happens internally with the bits. Okay, alright. So let's take another example, okay? 6 and 5. So what is 6 going to be? 8, 4, 2 and 1. And so 4, 5, 6, 0, 0. 4 and 5, 0, 0. So 0 plus 1, 0. 1 plus 0, 1. 1 plus 1, 0. 1 carry over and then 1. Alright. So first, in order to find plus synonym, what we are supposed to do is find something that is common, alright? See the pattern, alright? When you see the pattern, programming it is very different. It's going to be simply a cakewalk, it's going to be typically easy. Just write it in the paper, think, see, what do you see here, alright? So if you notice here, just look at it, and then you will notice that, see, this, everything is different, alright? So if it is, just look at these bits, alright? So 0, 1, 0, 0, 0, 1 has given me what? 0, 1, 1. What does it look like? If it is same, it is 0. If it is different, it gives me 1. Alright, let's check. So typically it tells it's XOR operation. Alright, let's check if what I'm thinking is right using this. Alright, okay, let's not consider the last bit, let's consider only the other bits before the last. So you get 1, 1, 0, 1, 0, 1 and you get the answer as 0, 1, 1. So if it is same, I get 0. If it is different, I get 1. So yeah, your assumption is right. XOR must be a part of this. So is only XOR enough? Definitely not, because you consider only the first 3 bits. Okay, it is very much evident that the last bit doesn't follow this rule. So something else must also be there. Okay, clear? Fine. So what else could be there? Let's look at it again. Okay. So why is this last bit actually varying here? Here, in both of the cases, the last bit is varying. Why? Because of these two ones here. That is, whenever I have a scenario of 1 and 1, and here again 1 and 1, the bit later is changing. Okay? So it is all because of what? This 1 and 1. So how can I find this, two consequent ones that's actually present? If it's 1, 0, 1, 0, 1, 0, 0, 1, I'll have to find out this. I'll have to find out this position. Alright. Similarly, for 0, 1, 1, 0, 0, 1, 0, 1, I'll have to know this position. That is, that position, what I mean is that I want an output like 1, 0, 0, 0. Similarly here, I want an output like, okay, when both these bits are set, I want to tell, okay, this is my, bit position wherein both are ones. I want some information like this. How can I get this information? Using what operator? Here, you can very much tell, can I use AND operator here? Right? So if we use AND operator, what is going to happen? If it is same, then only it's going to be true. Either way, it's going to be 0. Right? Only if both are ones, it's going to be 1. Otherwise, I'm going to get 0. What is it basically getting me? This one is basically giving me the carryover information. Can I tell it? Will tell no. Keep 5 in mind, 3 in hand, after 5, 6, 7, 8. Carry over. Right? So this 1 and 1, you add 0 here and 1 is carried over. It's because of these two ones here. And similarly, it's because of these two ones here. 1 in my 1 and 3 or whatever. You get 2. So you get a carry over here, right? It's because of two ones. And now I find the bit position of these two ones using the AND operation. So I also need the AND operation. But if you notice, no, with only this AND operation, nothing can be done. Okay, with only this AND operation, I get to know, fine. I get to know the position where it is present. But where is this one actually added? See, 1 0 1 0, 1 0 0 1. Okay, so I'm adding it, I get 1 1 0. I don't add 1 here. What is happening to the 1? I get the carry over information here, and the 1 is added to the next bit position right here, like this, right? So it is added to the next consequent bit position, not in the same bit position, which typically tells I'm not adding the carry, but rather I am adding what? Carry left shifted by 1 bit. Carry is left shifted by 1 bit. I am adding that. Can I tell you that now? So what is it typically? It is carry left shift 1. Right? So what is the operator I am using? Left shift. So these three operations sum up my addition. So this is how you are supposed to identify. Look at it, find typical patterns. So initially we started off with the last 3-bit pattern, and then we found the carryover using the AND operator. Then okay, using that carryover, I can typically tell no, I can't add it directly, but rather this carryover bit is added by 1 bit towards the left of wherever this is present. So I'll have to do left shift of the carry that I actually acquired, right? So this is the basic ideology. So using which I found out addition can be done with a synonym of XOR and left shift operator. Alright. So what let's write a program right now. So yeah, let's have this. So initially we saw with XOR. Alright. So first of all, we have to find out the carry. Wherever my carry is actually present, I have to first let us get the carry over. In carry is equal to what? How do you get the carry? Using the AND operator. Alright? Yes. So using this, I will get my carry over. Fine. And now let us have x is equal to what? X XOR y, which is going to give me what? The last most bits. Fine. The last most correct additional bits. And y is equal to the carryover. Okay. The carryover must be left shifted by 1 bit. The carryover must be left shifted by 1 bit. So when the carryover is keep on left shifted by 1 bit, until when should I carry this out? Is while y is not equal to 0. I'll have to carry this out. Alright, so let's see a quick walkthrough. If you didn't understand this course so far, it's totally fine. You understood, this concept, and let's get the walkthrough done right now. Alright. This is basically the program that we went through, and this is a typical addition that gets carried out. So let's have a quick walkthrough of this program. Alright. So carry is equal to x and y. Fine. So x is equal to what? 10. 8, 4, 2, 1. So y is equal to 9, 8 and 9. And so on, and what will happen? Only if both are true, I get 1. Else, any other case, I'm going to get 0. Fine. So this is going to be what? Carry. Carry is going to hold this. Fine. X is equal to x XOR y. Alright. So 1 0 1 0 XOR with 1 0 0 1. What will happen? XOR is that same means 0. Alright. Same is 0. Different is going to get the value of 1. So it's going to be 0 0 1 1. So x is going to hold what? 0 0 1 1. Fine. And y is equal to what? Carry is going to get left shifted. So rather than 1 0 0 0, I will left shift it by how many bits? 1 bit. Alright. So it becomes 1 0 0, which is what? The value is going to be 16 8 4 2 1. So the value of 8 gets converted into 16. Okay. So if you notice, well, there's another interesting fact. X is equal to what? This is 3 and y is equal to what? 16. Alright, add it. 19. What is your answer? X and y, 10 plus 9 is again 19. So you're basically, trying to put values, trying to, add different weightage of values and making, something of this format. You're trying to convert this into something like this. With y getting a value of 0, so that x will be your entire sum. Alright? So this is what you are actually trying to do using all these three operators. Fine? So does this make sense? So y is going to be this. So we have number 1, 2, 3. Alright? So right now y is not 0. Y has a value of 16 right here. Okay, so the loop gets carried again, and what will happen? Again, carry is equal to x and y. So x is going to be 0, 0, 1, 1. Alright, and y is going to be 1, 0, 0, 0, 0. Fine? Okay. When you do and, what will happen? There is no two consecutive ones. So what does it typically mean here? Okay, it typically means that there is only one bit of 1 and there is only one carryover taking place. Okay, and nothing more than one carryover. You don't have something like 1, 1, 1, 1, and you don't have two carryovers. You don't have two carryovers. You have only one carryover, and that is why in the next iteration itself the carryover becomes 0. Fine. And now carryover is going to hold the value 0. So now x is equal to x XOR y. XOR y is going to be, x is going to be 0, 0, 1, 1. Y is going to be 16 again. 1, 0, 0, 0, 0. So XOR 1, 1, 0, 0, 1. Look at it. You have arrived at the answer. Okay, and this gets stored in text. And now what is y going to become? Y is carry left shift 1. Carry is obviously 0. So no matter even if I do left shift, what is going to happen? It will again be 0, 0, 0, 0, 0, and another 0 will get added. Alright, it makes no sense. It's typically 0 only. So y is going to get the value of 0. So it will not go back again. Rather, y will not go back again because we have arrived at y is equal to 0. So you'll see our text. And what is the value of x? 1, 0, 0, 1, 1, which is what? 16, 8, 4, 2, 1. So 16 plus 2 plus 1, which is 19, which is the required answer. Alright, so we have added two numbers without using the addition operator. Very well, guys. So let's have, subtraction. How about without adding, you try to subtract two numbers without using subtraction operator. That would be even more great, right? So I'll have to use subtraction. So is it going to be the same or is it going to be different? There is a question. Okay. So just try this one out, alright? Before you look at the solution, just try this one out because it's going to be typically very simple. Alright, so just pause the video and I will suggest you guys, there is a very minor change you have to make in this code so that you get it for, and there's one more operator you have to use, and if you use that, you can use it for subtraction. Alright, it's basically the negation operator. It's negation x and y, you get the answer. Alright, so just do a code walkthrough again and write the program and check it out. Fine, so see you guys in the next question.